Greeting to my dearest lecturer. Today we will talk about drift velocity. Before we start, let's revise back what is an electric circuit. Here you can see there's an electric circuit connected to the battery and also a resistor. We all know the direction of electron will always be moving towards the positive terminal. And direction of current, however, will be opposing of the electron direction. As you can see from here, they will always, both electron direction and current direction will be opposing each other. And if we see the cross section area of a wire and we magnify it to a microscopic level, you can see there are a bunch of electrons and cations in it. So the question is, are these electrons moving, or are they moving really quickly, or are they moving very slowly? In order to answer this question, we need to understand the concept of drift velocity.
We all know that when a potential difference V is applied across a conductor of length L, an electric field will be produced inside the wire. The electric field strength causes an electric force F equals E times electrons to add on every free electrons. When the electrons are accelerated by electric field, they collide with the lattice atoms. The electrons will have a net velocity or an average velocity called the drift velocity. The drifting of the free electrons inside the conductor produce a net flow of charge. The net flow of charge is the electric current. The drift velocity of the free electrons is in the direction opposite to the electric field in the conductor. When there is a current flowing through a conductor, the free electrons have two kinds of motion. That is the high-speed random motion, which is about 10 power 5 meter per second, and slow drift motion. Note that it is the drifting motions that produce current, not the random motion. Although the drifting velocity is very small, but the effect of current is felt instantly when the current is turned on. This is because all free electrons in the circuit are moving at the same time. Even there is no power supply on the circuit, the electrons are still moving in high speed of random motion, but the net velocity of any free electrons over a certain period is equal to zero. Therefore, there is no net flow of charge nor electric current.
Let's move on to the formulas of drift velocity. The I represents the currents, and the N represents the free the electron's density. E means the electron charge, and A is the cross-sectional areas of wire conductor. Then V simply means the drift velocity. For more explanations about the derivations, I would recommend Khan's academics videos that explain drift velocity.
So does it mean that I can find the drift velocity through this equation?
Yes, we can find the drift velocity, which only requires currents, free electrons density, cross-sectional areas of wires, and charge of electrons, which is a constant. So let us look at these example questions. A current of 2.0 amperes flows through a copper wire of cross-sectional areas of 0.84 millimeter square. Calculate the drift velocity of the free electrons in the wire. Free electrons density of copper is equal to 8.5 times 10 to the power of 28 meters power negative 3. The solutions, by simply put into the values, we can find the drift velocities of free electrons. The drift velocities is equal to 1.75 times 10 to the power of negative 4 meter per second. That's all from us. Thank you.